And it's a go. All right, today 2.2, day number 1. Today's lesson is on implied domain and piecewise graphs. I am going to move through this at a decent clip, so I want you to stop me. I'll pause when you stop me. Remind me to pause it because I'll forget. I'm going to go through this at a decent clip. Okay, whoa. Mad Mouse Lab, we just talked about that. Those of you at home, figure it out. Function notation, right? We've got this function notation, y equals f of x. We talked about that a little bit. We're going to talk about domain and how the domain can be restricted not by looking at a graph anymore, but by looking at just the function itself, just at the equation, okay? And there's two ways to recognize whether or not a function has some sort of restriction on its domain. But before we do that, I want to talk a little bit about this function notation. I'm going to take this function g, and I'm going to add 4 to it, and then I'm going to multiply it by 3. I'm going to determine g of 5 first. So let's take this function g, and let's just say g equals x, right? And I add 4 and multiply by 3. PEMDAS is important. I add 4, I multiply by 3. That is going to be g of x. Okay, so g of x equals 3 times the quantity x plus 4. If I want g of 5, I plug 5 in for x. All right, I'm going to take that. That's my input. All right, and then I just compute. I simplify. Well, that's 9, and 3 times 9, that'd be 27. So g of 5 equals 27. Okay, applying them in this order is critical. If I were to multiply by 3, then add 4, totally different answer. All right, different answer altogether. Let's look at another one. Okay, this one is generic in nature, right? Meaning that there are no numbers involved. But if I take f of x, let's call f of x x, and I multiply by c, and then add t. Right? I don't need parentheses there, but f of x would be cx plus t. Well, what would f of 5 be? What variable do I plug 5 in for? X, right? So I plug it in. Oh, that's not all that pleasing because it doesn't simplify that well. Well, f of 5 equals 5c plus t. Oh, that's not pleasing. I didn't get a number. I'm so sad. I'll get over it. Well, if I plug in w and I take f of w and then I subtract t, f of w would be c times w plus t. That's f of w. And then I subtract t. So if I simplify that and get f of w minus t in simplest form, what would that equal? CW, yeah. Isn't that a TV station? Funny. No. What is it? Oh, 45. Is that it? I said 20. So what am I thinking about? Okay. All right. So generically simplifying function notation. Sweet. Okay. Here are the two restrictions on any function. You have to look for one of two things. You have to look for a denominator. The first thing we look for is a denominator. Let's take a function f of x, and let's call f of x 3 over x. Does it have a denominator? Yeah. What would be the problem with the denominator if it equaled what? 0. So we do not want denominator cannot equal 0. Okay, could the denominator equal 0? Here. Yes, if x equaled what? 0. So the implied domain of this problem would be negative infinity to 0, gap there, union 0 to infinity. Okay, how about this one? Let's go with h of x equals, I don't know, x plus 9 over 3. Does it have a denominator? Yes, but can the denominator equal 0? No, so there's no restriction on this domain. This domain would be negative infinity to infinity. Awesome. So we want to look at the function initially and say, does it have a denominator, yes or no? And can that denominator equal 0? If you say that denominator could possibly equal 0, that's the only restriction on the domain of that function. The other possible restriction, I don't like this green. This green is not visible. Very visible. Oh, gross. Okay. Let's make that purple for all those Vikings fans out there. Oh my gosh. Oh, you know what? I'm just going to highlight it. That'll bring it out of the... Oh, gross. For you Vikings fans, did it help? It did the opposite? Okay, let's change that. Well, let's change it to... Did that help? Did that help? Oh, that was helpful. Light green. Oh, yeah. How about this? Purple. Done. Oh, it looks a lot different there than it does. Hold on, I'm going to pause this. Don't worry, people at home. It only took me 8 minutes. I paused it for 8 minutes. Okay, the other thing you have to worry about is even radicals. Oh, weird. Okay. Why? Because if y, or f of x, scratch that, if f of x equals the square root of x, okay, Chuck Norris and Bruce Lee can divide by 0, and they can also take the square root or fourth root or sixth root or eighth root or even root of what kind of numbers? Negative numbers. So what we don't want here is for this item, what we call the radicand, this thing in here needs to be greater than or equal to 0. Otherwise, our calculator is going to freak out, right? Just like you do when, you know, your brand new chucks have a little scuff on them. Okay, that has to be greater than or equal to 0. Makes sense, right? I could take the square root of 0 or anything greater than that, but when I take the square root of -1, I get an imaginary number, and then we're into a different dimension. Okay. All right, so let's try a few. Okay, poison. Those are the two ways your math problems can be poisoned, okay? I don't know. Don't look at me. Somebody else thought of it. That's math poison. Dividing by 0. That's just what's going to happen to your calculator if you try to divide by 0 or take the square root of a negative number. It implodes. Okay, here we go. Does it have a denominator? Yes. Jack, could that denominator possibly equal 0? Yeah. What number would make the denominator equal 0? 0. So our domain is everything except for 0. Too easy. Done. Next one. F of x. Oh, sick. What the heck? That's a math problem. That's a gross math problem. Okay, hold on. Can you work, please? I want. Okay, I guess I'm going yellow, guys. First of all, we got a denominator within a denominator. So we're going to have two restrictions, and we want them both to be satisfied. So first restriction, we want this denominator, okay? We want x minus 3 to never equal 0. No, we don't want that to equal 0. So we cannot have x equaling 3. That's our first restriction. If x equals 3, calculator explodes. Second restriction, and we have to also, and we want this thing, 1 minus 4x over x minus 3. That cannot equal 0. Oh, this is when algebra gets fun. Okay, so how would I solve this? How about we subtract 1 from both sides? Okay, cool. We don't want that to work. Okay, if both are negative, could I just get rid of the negatives? Yep. So that works. Oh, no. No. So I'm just going to multiply both sides by -1. And wouldn't 1 really just be 1 over 1? Yeah. Do you remember cross multiplication? Pion. So I'm going to cross multiply. I'm going to take 4x times 1. I get 4x. I'm going to take x minus 3 times 1. I'm going to get x minus 3. And I'm going to solve this. You might have already solved it in your head. That's fine. I'm going to subtract. I get 3x equals -3. So x cannot equal what? -1. So I want For my restrictions, I want x to never equal 3, and I want x to never equal -1. Okay, so on the ends, I'm going to go off to infinity and negative infinity. And I don't want it to equal -1, and I don't want it to equal 3. So it can equal anything else. Too easy. Does that sit okay? All right. Is that a little bit more complicated than... Yeah, a little bit, but it's okay. So this is my domain. We haven't talked about range, but let's not worry about that. Let's not worry about that, okay? We're not going to worry about that. Let's go to the next one. Oh! I'm not going to worry about that. I'm not going to worry about that. It looks like Eddie's worried about it. He just about smacked something. He's like, I want to find a range. Okay. What did we just say about this? What does this have to be? Greater than or equal to 0. Oh, too easy. I got -3x greater than or equal to -4. But what happens with an inequality when you divide by a negative? L flipatorius. Yes. It flips. It flips. Negative divided by a negative is a positive. That's Greek, you guys. Deal with it. Okay. X is less than, X is less than or equal to 4/3. So I got a 4/3. Do I have a bracket or a parenthesis? Bracket. And it goes down to negative infinity. There's our domain. Let's do a couple more filthy ones. Oh, yuck. Oh, this is so good. I want 6 minus the square root of t plus 3 to be not equal to 0. Not equal to 0. That's equal. I want it not equal. And what's true about t plus 3? Yeah, it's going to be greater than or equal to 0. Oh, that's easy. So I want t to be greater than or equal to -3. Nice. And I want whatever this garbage is to work out. So I'm going to subtract. I get negative square root t plus 3 not equal to -6. Oh, they're both negatives. I'm just going to make them positives. Now what? Zach, square each side. Oh, no. Oh, square it. Square it. Okay, so if I square this side, I get t plus 3. And I square this side, I get 36. Okay, now this is where it's going to blow your mind a little bit. If I square a square root, if I square a square root, oh, you know what? No, we're good. We're good. It's if I take a square root of a square. That's when I have absolute value, okay? So here we're okay. Now we're just going to subtract, and t cannot equal 33. So these two things have to be true about our set. So t is greater than or equal to -3 and cannot equal 33. Is it true that this set satisfies both of those? It's greater than or equal to -3 and also cannot equal 33. That's the domain of that function. 33, fail, right? 33 makes the denominator equal to 0. -5, fail. That makes us take a square root of a negative number. Record. Welcome back. We have 57 seconds. We're going to do piecewise functions in 57 seconds. Y equals x. F of x equals x for x less than 0. Boom. Okay, less than 0. Well, the function y equals x would look like this. The dotted portion no longer exists because I'm limiting the domain of that function to less than 0. Boom. Done. Half of it, finished. Erase this garbage. How much time do I have? 29 seconds. The second half of the function, x squared, f of x equals x squared, will apply to greater than or equal to 0. Well, guess what? I'm going to fill in this circle because x squared at 0 is 0. And then I have the rest of that portion of that graph. Is it perfectly accurate in its sketch? Maybe not. But the red portion is x squared, and the blue portion is y equals x. Ta-da!